this video in English because it will be a lot more helpful to those that are going to install the channel expander from Circuit Domain, and in this particular case with the Razer radios board that has a special PLL installed in the board, and this technically gives you more channels. Of course, you really need to work on the bandwidth of the radio, but that's something that I'll do perhaps a separate video on. Here is the Circuit Domain board, the channel expander. I'm on version 2.6. The board version, I believe, is 2.8. Yeah, 2.8. It's from 2018. This board originally came with the firmware 2.5. I've already removed the 2.5 and installed the 2.6. And we're going to install this kit with the Razer radio board. To start with, we need to find the squelch tap, the PTT tap, and a point where you have 12 volts, 13 volts. Okay, so this is, here you have the on-off switch right here. Okay, you follow in the back. Here's what you have, 12 volts when the switch is turned on. Okay, so that's your 12 volts tap. Okay, when you turn on the switch, you get 12 volts. Excuse me, you get 12 volts here on this wire. Alright, and on the Razer radio board, you can see there you have 3 points where you're going to solder these wires. One is the PTT tap, number 1, which is the bottom one. Number 2 is a 12 volt, which is in the middle. And the top one is the squelch tap. Okay. So here's a 12 volt right here. This is the 12 volt tap. PTT tap on this 148. This is a Taiwan model. Okay, let me show you. Taiwan. Okay. This Taiwan model. See this white wire I'm holding? That's your PTT tap. Okay. You need to read the instructions to figure out which one is your PTT tap on your radio. On the Taiwan, right there, that's where the PTT tap is. Okay. Squelch tap, if you turn the radio around, will be here. This is where your squelch tap is. This radio will be a high squelch tap. What does that mean? If you read the manual, and again I reinforce, you must read the manual. Okay, don't try to install just by following my video. You need to read the manual to understand why certain things are done a certain way. The brown wire here is the PTT tap. When I excuse me, the squelch tap. When I close squelch on the radio, I have 6 volts in here. When I open the squelch and I hear the QRM or whatever static, then I go down to 0.0 something volts. Okay, so it's a high tap because when you close the squelch, you have a higher tension, higher voltage on close squelch, and this is all well explained in the manual. By the way, I have my manual here. Okay. Now the next step, and you got to do this first, right? This wire taps you got to do first, because you need to have the ability of turning the radio on and off and have reception before you remove any other components. You need to have reception to get you a squelch tap and your PTT tap. The 12 volts is easy. You don't need the radio to be working. You just need to figure out where you have 12 volts only when the radio is on. Now I'm following my page number 5 of the manual, and for my radio model 148 GTL PCB 412, where's my PCB? It's going to show upside down for you. Here you go. 412. It's showing upside down for you, okay? On my particular model, first I need to remove R95. It's a resistor, and it's the R95 resistor. Right here, the R95. R95 is right here. This is 96. This is 95. So you can see the PLL right here. R95 is here. This resistor needs to come off. Some people like just to cut off the one of the lags and call it a day. That may be helpful if you're thinking about, well, maybe I will just reverse all my changes and put back. By cutting this off and separating the lags, you can probably resolder if you want to put it back together. It's really up to you. Okay, so that's my next step. So here's R95. I removed the solder from the other side, and like I said, you do it the way you like. I did the way I like. I like to remove the whole component. Alright, so R95 has been removed. Next is remove capacitor C86 and C85, and we're going to place capacitor C86 where C85 once was. Okay, there is C85. You have your C86 and C85. Okay, so C85 is now where C86 used to be. The next step is to remove the PLL chip. That's this big boy right here. We're going to remove it. Okay, so PLL chip removed. It is MB8719, 8719, which is the Cobra 148 GTL PLL. It has been removed. So the next step is to remove the bezel of the radio, and of course first all the knobs, removing the knobs and the bezel so I can remove the channel selector. That's got to go too. It's going to get replaced with this little encoder with the 3-digit display. So this is going to go, this is going to go in. I'm going to have to do some type of adapter to place this, but when we get there I'll show you. So channel selector is being removed from here. That ribbon here is being removed. Here's the full channel selector, the original channel selector. It's been removed, so we're not going to need this, and this is going to go where the channel selector used to be. So here I'm going to adapt this little piece of board. It doesn't look beautiful, but it's going to be behind this, about these, call it front of the radio. And that's what's going to hold essentially the encoder. Okay, like I said, I'm not aiming for beauty, and this is going to be completely heating from my eyes once I put the radio back together. But it's going to work really well. It's a piece of PCB. Okay, and I think it's going to work out. So this is what it looks like after the board is set up with the little holes for the 2 screws, one on each side, and the center, of course, for the encoder. A reminder, this is an encoder that has a push function. Okay, so it has to be screwed in, because you're going to be pushing this encoder like so to change functions, and if this is not well screwed into the radio, this is going to fall back, and that's not going to be fun, right? If there is any question regarding this top part, yes, it is connected to the bottom part. You might be able to see through the light that there are circuit tracks connecting the top and the bottom part. The reason why they have holes in there, because you do have the option to break this off and connect this with wires if it's a radio where you can't really have this set up this way. Okay, so there's an option for you to break this apart and then use wires to connect the display to the encoder circuit. So that's what it looks like. Alright, so I have a bit of a situation here where this board here from Razor radios is not fitting properly where the old PLL was, because there's a very tall capacitor. Now, this capacitor has always been there. The best solution will be to essentially remove this capacitor and lay it flat here on the board, perhaps in this area. It's done. Capacitor will be fixed to the main board, but this is how the wiring is now. It gives me now space to attach the Razor radio board to. Perhaps I haven't mentioned that, and always, like I said, refer to the manual. You got to pay attention to pin 1 on the board, which is right here. This is little asterisk, and this is pin 1. Okay, on the radio, pin 1, as you see here, will be right here. Okay, here's pin 1. Oh, excuse me, right here. Here's pin 1. Okay, even though you see the little dot here, it doesn't mean that this is pin 1. Pin 1 is here. Okay, if you have the service manual for the radio, you can see that here is pin 1. This is the PLL. Here on this side is pin 1. On the left side, it's actually even marked in here with the little circles on the other side. There's a little square on this side. So pin 1 is here, and this is how the PLL was sitting on the board, like so. Okay, so therefore, by definition, put this over here. By definition, pin 1 is here. So we have to match with this board. Therefore, the board goes this way, not the other way around, this way. One more thing before placing the board on the radio, you do want to solder these 3 wires. The positive 12 volts, the PTT tap, which is the white one, and in my case also the brown one for the squelch tap. And they go soldered on this side. I'm gonna clean up a little bit here, but anyway, this is really the last step before putting the board on the radio. The board is now installed. You can see the wires managed through here between these components, and I have also shrink wrap here. Okay, so we'll need to adjust the L19. L19 is the coil that goes into the VCO pin 6. Alright, as you can see here on the service manual, he is L19, he is pin 6 of the VCO, such as it's stated here on the manual. Okay, but I also need to adjust the little red trim capacitor, which is here, to read on the frequency counter. I need to get a reading of 5.12 megahertz, so I'm going to do that now. So the adjustment I've made gave me a maximum of 5.119 megahertz. And how I'm connecting my frequency counter. Sorry, I accidentally paused the video. So yeah, let's see if this reading is good and acceptable, which is, I think it's pretty close, but I can't get any closer than that. This radio might really need a new set of capacitors. I need a recap of this radio, most likely. Anyway, this is what I have to work with right now. So I spoke with Ray and Mac from Circuit Domains, and Circuit Domain is Mac, and Ray is from Razor Radios. Ray advised that 5.119 is acceptable for the adjustment on the Razor radio board, so we're going to leave it as that. I've made some adjustments to L19, which is the coil that connects to pin 6 on VCO. Here is the channel expander, DigiMax 2.6, DigiMax Lite 2.6, and I'm going to place it now on the chassis of the radio. It's going to be quite above the board, the Razor radio board. Squelch adjustment, you need to close the squelch slowly until it squelches, if that makes sense. Okay, I got squelched, open, closed. Now I'm supposed to get a little dot over here. Remember, this is upside down. So the dot is with the radio upside up correctly, it will be on the right lower corner. So this little dot on the screen, top left corner, because radio is upside down, is not showing, and you adjust it on R16, which is on the board, is this trimmer right here, and you're going to turn it clockwise. From my point of view, it will be counterclockwise, but from the proper point of view is clockwise. Where is it? I got lost. Oh, here it is. Okay, so let's turn it until we see the little dot here. Slowly, there we go. It wasn't too far away. So when I open squelch, dot goes away. Put on squelch again. The dot's there. That is important because for the scanning function, the board needs to know when the radio is squelched so that it can scan properly. It also states that tension on pin 1, so voltage on pin 1 of U1 must not exceed 5 volts. So let's check that. Pin 1 ground, pin 1 ground. Just escaped from where it's supposed to be. Alright, so here you go. 5 volts. 5.01. So he also says check on TX mode. I also have 5 volts on TX mode. Turn squelch knob off and the dot should disappear. That's it. Yes. Yes, 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 yes. So the radio has a bunch of channels now, but I think most of them are useless. As far as like going way above to 10 meters, I don't want to go on 10 meters with this radio. So I'll try to see if I can manually set the highest channel to perhaps 99. Okay, but it does go up to and you can hear the VCO struggling at this point a little bit. It's got way too many channels. Strange, this one sounds loud. Alright, so we got negative 59, positive 252. I wonder if you will transmit on 252. Yeah, very low power though. It's transmitting with less than half watt. Stop it. And let's see if it's going to transmit on minus 59. Yeah, it's having trouble. It's having some trouble. See here, it's having some trouble. Minus 58 perhaps. There's the frequency, 26.3.